Almost coffee break. Everybody ready for the last presentation? Let's go. Hello, welcome everybody. My name is Anoek de Jonge, and together with Freek Beekhuis, we will represent Group 6. The past 8 weeks we've been working very hard on our paper. It's called Infrastructure Efficiency vis-à-vis Urban Configuration. Our presentation will follow the following structure. I'll introduce the topic to you in 4 slides, then 3 slides of methodology. Then Freek will take over with 4 slides of comparative analysis and then 6 slides of conclusion. Let's start. According to the United Nations, it is expected that in 2050, 70% of the world's population will live in cities, whereas in 1950, this was only 30%. This causes many concerns, since increasing population cannot go without growth of the city and also growth of the services. Services such as transportation in cities, which is vital for a city. And as you can see in China, they do not cope with that yet. In our paper, we aim to provide an overview of important characteristics for efficient transportation within a city. These can either be characteristics of a city or of a transportation system. For example, variables can be urban spread, high density, high rise, or public transportation. We focus on a special kind of sustainability, namely not only environmental friendly or energy efficiency, but we try to focus on durability of a city or of a transport system, and also efficiency of the transport system. We gathered 40 papers and articles, and we put them in a literature grid. Then we defined different independent variables to structure it, and then we derived 4 different methods: literature review, case studies, quantitative data analysis, and models. So here you see literature review and quantitative data analysis. Literature review is a qualitative research method. It aims to give a theoretical framework, whereas quantitative data analysis gives more factual insights. The next 2 methodologies are case studies and modeling, which both are mixed methods. And in the case studies, we compared 4 many future visions of 4 cities, which is very interesting. And the models were also mostly case studies, but can also give more insight on policies. Freek.
We compared the different. Hello. We compared the differences in our research methodologies, and if you look at case studies, they are more urged and constrained by reality because they are situated in reality, while literature reviews tend to make more general, abstract statements of which is better and why. The different research methods also, in general, aim to achieve slightly different things. Data analysis aim more at creating insight by numbers and providing graphs, while case studies aim to support new urban developments and why we should implement them or why not. If you look at the slide, you see our comparative analysis table, and at the left-hand side you see encircled in red, you see the variables we deemed important from our literature grid, and we focused our report on those, and we will go in depth in those later on in the presentation. If you see now, there are some vacant spots in the comparative analysis table. That's because some research methods aren't suited to research certain kind of things. And those differences are important to take into account if you're going to compare the different research methods. Now we see graphs of density. Our first important conclusion we drew from our report is that high density is important for transport, because how closely you are living together with each other, you have to travel less, you have to spend less time traveling, you have to spend less energy traveling. So that's the reason why living closely together is important. Another reason that really reduces travel time is mixed land use, because mixed land use, as shown here, reduces again the amount of travel you need to go to get to where you want to be, and thus reducing travel and thereby reducing congestion. Now we see a slide that depicts efficiency of transport modes, and we see our main transport mode, the car, being very inefficient. This is because it takes a lot of energy, a lot of place, it wears the infrastructure down quite a lot, and there are efficient other transport modes like cycling and walking. So we should focus on cycling and walking infrastructure. This is because cycling and walking infrastructure would shift the usage from cars to more sustainable and efficient ways of movement, being cycling and walking. Another important point is that it also makes the rest of the transport modes more accessible. If you can access the transport hubs for the urban transport systems more easily, more people will use them, and again the usage will shift from car usage, which is inefficient, to urban transport. If we talk about what is a good configuration for a city, we came to the conclusion that that clusters of high density urban tissue around the transport modes is very important, because this again makes the transport hubs more accessible. I want to conclude the presentation with a slide of how we think which is a good solution of urban transport. We'd like to thank you for your attention. Are there any questions left?
Just do themselves.
Yes?
I have a question, because you showed the example of high-rise buildings, but you need to transport yourself vertically and not horizontally. Is there a difference, or
Yes.
is it better when you transport yourself vertically?
Let me first explain. This is not per definition high-rise. This is a high-density graph in 3 directions, but still it will result in high-rise mostly, or very compact building. But still, if you have to transport yourself over 3 axes or over 2 axes, the difference is that you have a lot more options of travel, and your total travel time will still reduce even if you have to travel vertically, because you have 3 axes to travel on, you can travel more efficiently.
Then you get to multi-level transportation, and that's something very new, so we did not really take it into account because only a few papers talked about it. So we focused more on the high density part.
Yes, I understand. Okay, thank you.
Any other questions?
Like that.
Rob?
Your last slide with one that you said you thought was a good example for urban transportation. Which one? Why is this so good?
That's public transport.
Why is this good? Yeah, well, first it looks pretty. That's important for a slide. But to go somewhat more in depth on why, if you see the urban transport network, oh hey, that's funny, is incorporated really within the urban structure. It is interwoven with the urban structure, and it's not just a measure that is put there from the top. It's really part of the city, and that makes it more efficient. You can see it's right through a high density urban tissue, so there are a lot of people that can access the transport points, and that makes it more used. It's Tokyo, by the way.
But there's one characteristic missing. Who knows? Cycling and walking. Yeah. Okay. Other questions? Anna.
No, there's another one.
Oh,
Yeah?
Yeah.
Yes. I was wondering if is your ideal picture of the future cities, I don't know how to say, but is it that you have high-rise buildings and multiple levels on which there's public traffic, or because you both mentioned that 2 types, high-rise buildings and a lot of traffic.
Yeah, that's true. I think we aim to find the perfect model for a city. but that's somehow difficult because cities in America and Asia and Australia differ very much from their own structure. So we think ideally that's what it should look like, but we try to focus on just different characteristics, so each city could apply those characteristics for itself. I think that's sufficient answer. Another question? Yeah.
How do you think transportation of goods in those high-density cities is to be done? Because I think that would be harder. Everything is so dense that maybe the
transportation of goods and infrastructure. I mean, we how do you say that? We try to shift the usage from the roads because roads is an efficient way of travel at the moment. There are some very futuristic things going on, like railway systems that go underground solely for goods only. But that's again very much, it's actually out of our scope. We are focusing on transport infrastructure and on what is more sufficient and what's not like far in the future, but more for, well, let's say 10 years, what can we focus on the next 10 years instead of really talking about that kind of things.
Yeah, well, I think it's a very interesting question, but it was out of our scope. So.
I'll do one within your scope. And before we finish, then we go to the coffee break. Because your main goal was to discover what other researchers were doing as a state of the art. Would you say that already this cycling approach and the short distances and the mixed use is already there in the literature as being recommended and proved effective? Or is something that you would still suggest as further research to be even more studied? Was it already there, or as a majority, everyone on all the articles were tackling it, or is it something you think it's there but it's not yet developed enough?
I think it's a bit of both, because we have a lot of cities we looked into, and it's there are some research that proves data, that give data that hint at that it's the best solution at the moment. So, but there are also sometimes some cities already apply some of the things we mentioned here, and say they get very good results from that. So it's a bit of both worlds. It's there's data.
Is it a process, like, because before you start with cycling, you cannot have the single use, otherwise you do kilometers with your bicycle. So you first need to start transforming into a mixed use city, and then after
it's all comes together, and we put there are reports on aspects alone, but also on the aspects together with each other.
Okay.
And we drew synthesis from all those collective reports to make our conclusion for what we think should be done and what should be researched more thoroughly, but also experimented on, because cities are very much living things, and you can draw conclusions from behind your computer, but you also have to experiment them in real life to find if they really work like you imagined.
So I look forward to your master paper in 1 year. Thank you very much.
Thank you for the last discussion.